Picture this: a colossal spacecraft, sleek and silent, gliding through the infinite blackness of space. Suddenly, the fabric of reality twists, bending like a ribbon, and the ship vanishes into a swirling vortex, a wormhole, a cosmic shortcut through the universe. For centuries, humanity has stared at the stars, dreaming of the day we might cross those unimaginable distances. But here's the haunting question: what if we're not the first? What if, long before we even thought to build rockets, something or someone had already mastered the art of intergalactic travel? The idea isn't just science fiction. It's a possibility that shakes the foundations of everything we think we know about the cosmos. Today, we're diving into 30 mind-bending theories about the universe's very first intergalactic travelers. Some of these ideas sound like they're ripped straight from the pages of a cosmic thriller: ancient alien civilizations wielding technology beyond our comprehension, rogue black holes acting as natural highways between galaxies, or even beings made of pure energy slipping through dimensions we can't even perceive. And then there's the most unsettling thought of all. What if their journeys left traces behind, faint signals buried in starlight, mysterious structures orbiting distant suns, or echoes of their presence hidden in the oldest corners of the universe? This isn't just about wild speculation. It's a journey into the deepest mysteries of existence, where science, imagination, and the unknown collide. Each theory we explore is a piece of a puzzle so vast it rewrites our place in cosmic history. So buckle up. By the time we're done, you'll never look up at the night sky the same way again. Because out there in the endless dark, the truth might be waiting, and it's far stranger than anything we've dared to dream. The first theory takes us way back, to a time before Earth even existed. Imagine a civilization so advanced they mastered the stars not by sending living explorers, but by dispatching tiny, self-replicating scouts into the void. These wouldn't just be ordinary probes, they'd be something far more intriguing: von Neumann machines, named after the visionary scientist who first dreamed them up. Picture a fleet of autonomous robots, each capable of harvesting raw materials from asteroids or moons, building exact copies of themselves, and launching those copies toward new star systems. Over millions or even billions of years, these probes could spread like a cosmic wildfire, crossing entire galaxies without a single biological pilot ever leaving home. Now here's where it gets eerie. If such probes did exist, why haven't we found one? That's the heart of the Fermi paradox, the glaring contradiction between the high probability of alien civilizations and the total silence we hear from the cosmos. One chilling answer: the probes might already be here, lurking in our solar system, disguised as natural objects or buried beneath the ice of distant moons. They could be observing us right now, silently waiting, their purpose long forgotten even by the civilization that built them. But there's another twist. What if these probes aren't silent? Some scientists speculate that ancient alien technology might be hiding in plain sight, embedded in strange radio signals, or even encoded in our own DNA. Far-fetched maybe, but consider this: if a probe arrived on Earth billions of years ago, when life was just beginning, could it have tinkered with the building blocks of biology itself? The idea blurs the line between science and speculation, but that's what makes it so thrilling. After all, if the universe is as old as we know it to be, why wouldn't someone have tried it? Now, let's stretch the imagination even further beyond probes and into the very fabric of the universe itself. Picture spacetime not as smooth and uniform, but as a tangled web of cosmic threads, remnants of the universe's violent birth. These aren't just theoretical oddities, they're called cosmic strings, hypothetical cracks in reality so dense, a single inch could weigh more than a mountain. And if they exist, they might hold the key to the ultimate shortcut, faster than light travel without breaking the laws of physics. Here's how it could work. Cosmic strings warp space-time around them, bending it into steep gravitational slopes. If two strings were to cross or loop together, they could create a tunnel, a natural wormhole linking two distant points in the universe instantaneously. An advanced civilization wouldn't need to build warp drives or spend centuries crossing interstellar voids. They'd simply hitch a ride along these cosmic superhighways, surfing the wrinkles of spacetime itself. But why stop at just using them? Imagine a species so advanced they learn to manipulate these strings, tying them into knots, weaving them into networks, or even stretching them like cosmic suspension bridges between galaxies. The energy required would be unimaginable, but for a civilization that's mastered the universe's fundamental forces, it might just be another engineering problem. The most haunting part, these strings could still be out there. Unlike wormholes, which might collapse without constant upkeep, cosmic strings could persist for billions of years, their gravitational fingerprints subtly warping the paths of stars and galaxies. Some astronomers have even scanned the skies for their telltale distortions, strange lensing effects, or unexplained ripples in the cosmic microwave background. If they ever found one, it might not just rewrite physics textbooks, it could reveal the ruins of an ancient interstellar transit system, abandoned by its builders long ago. And that raises a spine-tingling question. If someone did use these strings to cross the cosmos, where did they go? Did they vanish into higher dimensions, ascend to some unknowable state of existence, or are they still out there, riding the cosmic currents, so far beyond us that we're like ants staring up at a skyscraper, oblivious to the civilization towering overhead? One thing's certain, if cosmic strings are real, the universe might be far more navigable than we ever dreamed. And if someone else figured that out first, well, the stars might not be as lonely as they seem. Black holes already warp our understanding of reality, cosmic vacuum cleaners so powerful, not even light can escape their grip. But what if some of them aren't just traps? What if, hidden among them, are the universe's oldest and most efficient shortcuts? Enter primordial black holes, hypothetical relics from the first moments after the Big Bang, tiny yet impossibly dense. Unlike the colossal black holes formed from dying stars, these could be as small as a pinprick, weighing as much as a mountain. And according to some physicists, they might be the keys to unlocking the cosmos. Here's why. Primordial black holes are thought to have formed when the newborn universe was still a seething, chaotic soup of energy. Quantum fluctuations, tiny ripples in spacetime, could have collapsed into ultra-dense knots, creating black holes by accident. And if they exist, they might not behave like the ones we're familiar with. Some theories suggest these ancient objects could be entangled with other black holes, forming bridges through spacetime, Einstein-Rosen bridges, better known as wormholes. A species advanced enough to locate and stabilize one of these natural tunnels could leap between galaxies in the blink of an eye. But how would it work? Imagine a civilization that's mapped the cosmos not by star charts, but by black hole networks. They'd need technology capable of surviving a black hole's crushing gravity, perhaps force fields that twist spacetime itself, or probes made of exotic matter to keep the wormhole's throat from collapsing. Once stabilized, these portals could function like interstellar subway stations with whole armadas zipping through them. It's a staggering thought. The universe might already be threaded with a hidden transit system, built not by engineers but by the Big Bang itself. Now the real twist. If an ancient species did use these shortcuts, we might never find their ships or cities. Instead, their legacy could be written in the black hole's movements. Strange, unexplained shifts in a black hole's spin or trajectory might hint at artificial manipulation, like finding tire tracks on a dirt road. Even stranger, some primordial black holes could still be drifting through our solar system right now, invisible and undetectable unless they pass right in front of a star, warping its light like a lens. And that raises a tantalizing and unsettling possibility. What if these black holes aren't just natural? What if some were placed, a super-advanced civilization might have harvested them, nudging them into stable orbits to create a lasting transportation grid. The evidence wouldn't be in metal or signals, but in the gravitational fingerprints they left behind. Astronomers are already scanning the skies for anomalies, black holes moving too fast, or in patterns that defy physics. If they ever find one that doesn't fit, it might not just be a scientific curiosity. It could be a signpost left behind by the universe's first travelers. So the next time you hear about a black hole devouring a star or bending light in strange ways, ask yourself, is it just nature running its course, or is it the echo of a billion-year-old highway built by beings who mastered the cosmos long before Earth even existed? The universe keeps its secrets well, but not forever. Imagine an entire civilization slipping between the stars not by brute force propulsion, but by vanishing from one point and reappearing in another, like a phantom stepping through walls. This isn't magic, it's quantum tunneling, one of the universe's most bizarre loopholes, and if harnessed, it could rewrite the rules of intergalactic travel. At the subatomic level, particles pull off this trick all the time. An electron trapped behind an energy barrier it shouldn't be able to cross will occasionally just blink to the other side, as if the barrier wasn't even there. It defies classical physics, but quantum mechanics shrugs. Reality, it seems, has a tolerance for cheating. Now, stretch that idea to a cosmic scale. What if an advanced species learned to orchestrate this phenomenon not just for particles, but for entire starships? The math, surprisingly, doesn't forbid it. Quantum tunneling works because particles exist as probability waves, fuzzy clouds of maybe until they're observed. In theory, a ship could exploit this uncertainty. By manipulating its quantum state, it might momentarily dissolve into a wave function, bypassing light years of space in an instant, then reconstitute itself at the destination. No warp drives, no wormholes, just the raw, unfiltered weirdness of quantum mechanics bending the rules. Of course, the obstacles are staggering. For one, the probability of tunneling decreases exponentially with mass and distance. A single atom might tunnel through a nanometer-thick barrier relatively often, but for something as massive as a spacecraft, the odds become vanishingly small, like waiting for a million dice to all roll sixes simultaneously. But here's where engineering could intervene. A civilization mastering quantum manipulation might amplify those odds by creating artificial barriers with precisely tuned energy fields, or by chilling their ships to near absolute zero, reducing quantum noise. Some theories even suggest that conscious observation could collapse the wave function favorably, meaning the act of intending to tunnel might nudge reality toward making it happen. The implications are dizzying. If tunneling were possible, travelers wouldn't just hop between stars, they'd sidestep the very concept of distance. A ship could appear inside a locked vault, a sealed bunker, or even the heart of a star, no entry required. Surveillance would be meaningless, defenses obsolete, and the evidence practically invisible. Unlike warp bubbles or wormholes, quantum tunneling leaves no gravitational ripples or radiation trails. The only clue might be a flicker of particles where the ship wasn't a ghostly absence in the fabric of space. But here's the haunting thought. If a species cracked this technology eons ago, why wouldn't they be among us already? Not as physical visitors, but as spectral hitchhikers, slipping through the quantum static of our own atoms. We might never detect them, not because they're hiding, but because they're playing by rules we're only beginning to grasp. And that raises the ultimate question. In a universe where reality itself is this fluid, who's to say we're the ones who have been left behind? Quasars are among the most violent objects in the cosmos, supermassive black holes at the hearts of distant galaxies, devouring matter so voraciously they outshine entire galaxies. The energy they release is staggering, a cosmic bonfire burning with the power of 1 trillion suns. Now imagine a civilization so advanced, so ambitious, they didn't just tap into stars for energy, they went straight for the most extreme power source in the universe. What if the first intergalactic travelers didn't build Dyson spheres around ordinary stars, but around quasars themselves? The concept of a Dyson sphere, a megastructure enveloping a star to capture its energy, has been around for decades. But scaling that idea up to a quasar, that's engineering on a mind-bending level. A quasar's energy output is concentrated in a region smaller than our solar system, meaning a structure built around one wouldn't need to be physically enormous. Instead, it would need to withstand conditions so extreme they defy imagination. Think of a swarm of mirrors or energy collectors orbiting at the edge of the black hole's event horizon, bathed in relentless radiation and gravitational tides strong enough to shred planets. Yet if a civilization could pull it off, the payoff would be unmatched. The energy harvested from a single quasar could power faster than light travel, sustain entire fleets of starships, or even fuel the creation of artificial wormholes. But how would we detect such a feat? The clues might be hidden in the quasar's light. Normally, quasars flicker unpredictably as they consume matter. But if something artificial were siphoning their energy, we might see unnatural patterns, regular dips in brightness, or emissions skewed toward specific wavelengths, as if the light were being filtered or redirected. Even stranger, a quasar wrapped in a Dyson-like structure might suddenly vanish from our telescopes altogether. If the megastructure captured all the outgoing energy, the quasar would go dark, leaving behind only the gravitational signature of its central black hole. Astronomers have already catalogued mysterious, disappearing quasars, objects that flared brightly for centuries, then winked out inexplicably. Could some of these be evidence of cosmic construction projects on a scale we can barely comprehend? And there's another tantalizing possibility. What if we've been looking for Dyson spheres in the wrong places? Most searchers focus on stars with unexplained dimming, but a quasar Dyson sphere wouldn't dim, it might just change. Its light could carry the fingerprints of alien technology, like telltale waste heat or artificial modulation. Some researchers suggest scanning quasars for signs of deliberate engineering, like laser-like beams of energy directed toward specific points in space. But the wildest thought of all, a quasar's energy might not just fuel ships, it could launch them. Simulations show that the relativistic jets blasting from quasars could, in theory, be harnessed as cosmic railguns, accelerating vessels to near-light speeds without onboard fuel. An advanced species might ride these jets like surfers on a wave, using them to slingshot across intergalactic distances. If so, the universe's first highways weren't built. They were borrowed, carved out by the raw power of nature itself. So the next time astronomers spot a quasar behaving oddly, it's worth asking, are we witnessing the tantrums of a black hole or the signature of something far more extraordinary? Out there, in the raging hearts of distant galaxies, the remnants of an ancient supercivilization might still be humming with power, waiting for us to notice. What if the answer to the mystery of the first intergalactic travelers isn't out there among the stars, but up ahead in our own distant future? Imagine a scenario where humanity doesn't just reach other galaxies but conquers time itself, looping back to shape the universe's history long before we ever left Earth. This isn't just a twist on time travel stories, it's a radical reevaluation of our cosmic significance. Think about how time operates on a universal scale. The universe is roughly 13.8 billion years old, but if a civilization cracked the code of time manipulation, they could effectively have infinite time to explore. Future humans, or whatever we evolve into, might not need generational ships or cryo-sleep to cross galaxies. Instead, they could use time as a dimension to fold space, arriving in the past at their chosen destination. A ship could depart from Earth in the year 50,000, travel for a century, then activate a time jump mechanism, reappearing near the same coordinates but billions of years earlier. The implications are staggering. Now consider the artifacts they might leave behind. If future humans wanted to guide their own evolution, or simply leave markers of their existence, they could have embedded clues in the fabric of reality itself. The Fibonacci sequence in sunflower spirals, the precise alignment of ancient megaliths with celestial events, even the eerie similarities between distant mythologies describing sky gods. What if these aren't coincidences or the work of aliens, but deliberate breadcrumbs left by our distant descendants? The universe might be littered with their signatures, hidden in plain sight. Here's where it gets even stranger. If time travel were possible, causality becomes fluid. A future civilization could engineer its own rise by influencing the past, ensuring the conditions for its existence. This creates a paradox loop. Did they invent time travel because they found ancient technology, or did they plant that technology to ensure they'd invent it? The line between cause and effect blurs into infinity, but how would we ever detect such travelers? Unlike alien visitors, time-traveling humans wouldn't need to cross space. They'd sidestep it entirely. Their presence might only reveal itself through anomalies, particles behaving contrary to known physics, ancient artifacts with impossible metallurgical compositions, or even gaps in the fossil record where life inexplicably leaps forward. Some scientists speculate that certain quantum phenomena like particles appearing to remember their future states could be the faint echoes of time manipulation on a microscopic scale. The most haunting question isn't whether this is possible, it's why they'd stay silent. If humans from the future are already here, woven into the past, their silence might be deliberate. Maybe revealing themselves would collapse the timeline. Or perhaps they're waiting, observing their own origins like scholars studying a history they're forbidden to alter. One thing's certain, if this theory holds even a grain of truth, then every moment of human history, every discovery, every catastrophe, every leap forward might already be part of a story whose authors are us, rewritten across eternity. Dark matter is the universe's greatest unsolved mystery, an invisible, intangible substance that makes up over 80% of all matter, yet refuses to interact with light or anything else we can detect. We only know it's there because of its gravitational pull, silently holding galaxies together like cosmic glue. But what if dark matter isn't just a passive backdrop to the cosmos? What if, billions of years ago, an advanced civilization figured out how to harness it, not just to understand the universe, but to reshape it? Think about how dark matter behaves. Unlike normal matter, it doesn't clump into stars or planets. Instead, it forms vast, diffuse halos around galaxies, its gravity sculpting the paths of stars like an unseen hand. Now imagine a species that learned to tap into those halos, using them as fuel or even as a propulsion system. The energy potential would be staggering. Dark matter doesn't collide, absorb, or emit light, meaning a ship powered by it wouldn't need traditional engines. It could ride the gravitational currents of the cosmos, surfing the invisible tides between galaxies without leaving a trace. But here's where it gets eerie. If such technology existed, how would we even spot it? The answer might lie in the very thing that revealed dark matter's existence in the first place: anomalies in galaxy rotation. Stars on the outskirts of galaxies move far faster than they should, a telltale sign of dark matter's pull. But what if some galaxies spin too perfectly, their rotations too finely tuned? That could hint at artificial manipulation, like finding a river whose currents flow in precise, unnatural patterns. Some astronomers have already noticed strange outliers. Certain dwarf galaxies, for example, have dark matter distributions that don't match theoretical models. Others show bizarre, lopsided halos, as if something had scooped out chunks of the invisible stuff. Could these be the scars of ancient engineering projects, where a civilization mined dark matter like we mine coal, leaving behind gravitational pockmarks? Or worse, what if they're not scars at all, but active experiments? zones where dark matter is being concentrated or redirected for some unfathomable purpose. The most unsettling possibility, dark matter might not just be a tool, it could be a weapon. Picture a species capable of compressing dark matter into dense, artificial knots, creating gravitational lenses so powerful they bend light into traps or focus cosmic rays like a death beam. A single manipulated halo could fling stars out of their galaxies or collapse entire systems into black holes. The evidence would be subtle, just a faint wobble in starlight or a galaxy that spins a little too smoothly as if held together by strings. But here's the twist: if a civilization mastered dark matter, they might not even need to travel in physical ships. Their bodies, or whatever they've evolved into, could merge with the dark halo itself, becoming one with the invisible fabric of the universe. They wouldn't visit worlds, they'd embody the space between them. To them, we might not even be visible, like ants crawling on a painting, unaware the canvas itself is alive. So the next time astronomers map a galaxy's rotation and find a tiny, unexplained deviation, ask yourself, is it just the randomness of nature, or is it the signature of something older, smarter, and far darker than we ever imagined? The universe's first travelers might not be in the stars, they might be the darkness behind them. Deep beneath the forest floor, hidden from sight, lies a vast, intricate web, mycelium, the fungal network that connects trees and plants in a silent, symbiotic dance. Now stretch that idea across the cosmos. What if galaxies, like ancient forests, are threaded together by an invisible lattice, a subspace mycelium weaving through the fabric of spacetime itself? This isn't just poetic speculation. It's a theory that blurs the line between biology and cosmology, suggesting the universe might be alive in ways we're only beginning to fathom. The concept hinges on a radical reimagining of space's structure. Just as mycelium transmits nutrients and information between trees, this cosmic network could facilitate instantaneous travel, not through wormholes or warp drives, but through filaments of quantum entanglement or higher dimensional threads. Imagine a starship not as a vessel plowing through space, but as a spore hitching a ride on the galactic equivalent of a fungal hypha, slipping effortlessly between nodes in the network. The distances we see as impassable voids might simply be gaps in our perception, like an ant unaware of the highways crisscrossing above its head. Where does this idea come from? Surprisingly, it's rooted in two seemingly unrelated fields: psychedelic experience and panpsychism, the philosophy that consciousness is a fundamental property of the universe. Psychedelics, particularly compounds like psilocybin, often evoke visions of interconnected webs or grids, described by users as the fabric of reality. These reports are anecdotal, yes, but they echo a provocative hypothesis. What if these experiences aren't just hallucinations, but fleeting glimpses of the universe's true structure? Meanwhile, panpsychism suggests that even particles might possess a rudimentary form of awareness, implying the cosmos itself could be a vast, thinking network, with mycelium-like pathways as its neurons. Here's where it gets stranger. If such a network exists, it might explain the eerie synchrony of cosmic events. Galaxies billions of light-years apart sometimes rotate in uncanny alignment, as if guided by an unseen hand. Quantum particles entangled across vast distances react instantaneously, defying classical physics. Could these be traces of the mycelium's influence, subtle pulses traveling its tendrils? Some theorists propose that advanced civilizations wouldn't just stumble upon this network, they'd cultivate it, nurturing its growth like cosmic gardeners, expanding its reach to new galaxies. But how would we detect something so ephemeral? The answer might lie in quantum noise, the faint static at the edge of spacetime. Just as trees communicate through chemical signals, the mycelium might broadcast through quantum fluctuations, patterns hidden in the cosmic microwave background or the spin of distant particles. Unusual bursts of neutrinos or anomalies in dark energy distributions could be its fingerprints. Even gravity waves, those ripples from colliding black holes, might carry signatures of the network's vibrations like plucked strings resonating across dimensions. And then there's the most unsettling implication. If the universe is a living network, who or what might already be navigating it? Civilizations immeasurably older than ours could have long since merged with the mycelium, their consciousness diffused across its threads. They wouldn't need ships or planets. They'd exist as pulses of information dancing along the cosmic web. To them, our frantic rockets and radio signals might seem quaint, like smoke signals beside fiber optic cables. So the next time you gaze at the night sky, consider this. The darkness between stars might not be empty at all. It could be thrumming with invisible pathways, a labyrinth of living spacetime waiting for us to learn its language. And if we ever do, the universe won't just open its doors. It might reach back. Picture a ship with sails so vast they could catch the wind between galaxies, but not the wind as we know it. These sails wouldn't billow with air or shimmer with sunlight. Instead, they'd stretch across light years, gossamer thin and nearly invisible, designed to harness the most elusive particles in the universe, neutrinos. Trillions of these ghostly particles pass through your body every second, zipping through matter as if it weren't even there. But what if an advanced civilization found a way to make them push? The concept builds on an idea we're already exploring today: solar sails. These ultra-thin mirrors capture the faint momentum of photons, using light itself as propulsion. But for intergalactic travel, sunlight is far too weak. The nearest star's photons would be a whisper against the void. Neutrinos, though, are different. Born in the cataclysmic hearts of supernova, merging neutron stars and active galactic nuclei, they flood the cosmos in staggering numbers, carrying energy that dwarfs even the brightest stars. A sail designed to interact with them could, in theory, ride this relentless neutrino wind across the abyss. Here's how it might work. Neutrinos rarely interact with matter, but when they do, they transfer a tiny amount of momentum. A sail made of degenerate matter, a super-dense material like that found in neutron stars, or laced with quantum-scale detectors, could increase those interactions. Picture a mesh so finely tuned, it vibrates when struck by neutrinos, each impact adding a minuscule nudge. Over centuries, those nudges would compound, accelerating the ship to velocities impossible for conventional rockets. The sail itself might span millions of kilometers, a fractal web of filaments barely thicker than atoms, shimmering like a cosmic spiderweb in the dark. But the real genius lies in the neutrino sources. Unlike sunlight, which fades with distance, high-energy neutrinos stream uniformly from violent events across the universe. A civilization could plot courses along these cosmic currents, hopping from one neutrino fountain to the next, a supernova here, a quasar there, each acting as a natural booster. They might even create their own sources, detonating artificial supernova or manipulating neutron star collisions to blast out precisely timed neutrino surges, effectively laying down interstellar tailwinds for their fleets. The challenges, of course, are staggering. Neutrino interaction rates are absurdly low, meaning the sails would need efficiencies beyond anything we can currently conceive. Radiation from nearby neutrino sources would fry organic crews, implying ships might need to be autonomous or crewed by radiation-resistant synthetic life. And then there's the time scale. Accelerating to meaningful speeds could take millennia. But for a patient species, or one that's mastered biological immortality, time might be no obstacle. Now consider the evidence such technology would leave behind. A neutrino sail wouldn't emit light or radio waves, but it might distort the very neutrinos it harvests. Telescopes designed to detect neutrino anomalies could spot strange shadows in the particle flow, regions where neutrinos scatter or dim as if something vast and invisible were siphoning their energy. Even eerier, if multiple civilizations used this method, their sails might form a detectable pattern, like buoys marking an interstellar shipping lane. And that raises a profound question. If neutrino sails are possible, why haven't we found one? Perhaps they're already here, drifting unseen through our solar system, their sails furled, waiting for a wind we can't feel. Or worse, what if we're looking for the wrong thing? A sufficiently advanced sail might not just catch neutrinos, it could steer them, bending the particles into focused beams. A neutrino lighthouse signaling across the cosmos would be invisible to our eyes but blazingly obvious to anyone who knew how to look. So the next time a supernova flashes in the night sky, remember, its light is just the fireworks. The real energy is in the neutrinos screaming through space at nearly the speed of light. And somewhere in the darkness between galaxies, an ancient ship might be riding that storm, silent, relentless, and so far ahead of us we haven't even learned to see it yet. What if everything we perceive as reality, every galaxy, every atom, every law of physics is just a flickering projection, like light dancing across the surface of a deeper, hidden dimension? This isn't science fiction. It's the holographic principle, a radical theory suggesting our three-dimensional universe might actually be encoded on a two-dimensional boundary at the edge of, well, everything. And if that's true, it opens a terrifying possibility. The first intergalactic travelers might not have moved through space at all. They could have hacked reality itself. Think of the universe as an immeasurably complex computer simulation. Just as a video game renders a 3D world from 2D code, the cosmos might emerge from information etched on some distant cosmic horizon. Now imagine a civilization so advanced they didn't just understand this code, they learned to rewrite it. Not everywhere, of course, that would take infinite energy. But in small, localized pockets, they could tweak the rules, bending physics to their will. Want to cross 1,000,000 light years in an instant? Reprogram the hologram so that two distant points in space temporarily overlap. Need to survive the crushing gravity of a black hole? Adjust the quantum date to defining mass and force in your immediate vicinity. The universe to them wouldn't be a fixed stage, it'd be a malleable interface. Evidence for this might already be hiding in plain sight. Quantum entanglement, where particles instantly influence each other across vast distances, defies classical physics. But if the universe is a projection, entanglement makes perfect sense. The particles aren't communicating faster than light. They're pixels linked at the code level. Similarly, dark energy's mysterious expansion of space could be a glitch or artifact in the hologram's rendering. And then there's the Boltzmann brain paradox, the statistical likelihood that a self-aware consciousness could randomly arise from quantum fluctuations. Unless, of course, those fluctuations are deliberate edits by something or someone tinkering with the source. The scariest part, if a species mastered holographic hacking, they wouldn't leave behind Dyson spheres or wormholes. Their artifacts would be subtler, regions where the laws of physics inexplicably shift or particles behave in ways that shouldn't be possible. Astronomers have already spotted anomalies, cosmic voids where matter is suspiciously sparse, or stars moving as if tugged by invisible strings. Could these be the fingerprints of a universe where the code has been rewritten? And that raises the ultimate question. If reality is a projection, who's running the projector? Are we just unprivileged users in a cosmos where others have admin rights? The truth might be stranger than we dare admit, because if the holographic principle is real, the first travelers didn't conquer space. They debugged it. The universe didn't just expand after the Big Bang, it exploded outward faster than the speed of light, a runaway stretching of spacetime so violent and sudden, it makes supernova look like firecrackers. This was cosmic inflation, the universe's first and most extreme growth spurt, lasting mere fractions of a second but magnifying the cosmos from smaller than an atom to something approaching its present scale. And here's the jaw-dropping thought. What if someone or something rode that wave? Imagine a civilization so advanced they didn't just survive the Big Bang's aftermath, they harnessed it. Inflation wasn't just expansion, it was space-time itself tearing open, creating bubbles of reality where the laws of physics could vary wildly. If a species had somehow anchored themselves to this accelerating fabric, they could have been flung across the cosmos in an instant, their ships or structures stretched to sizes beyond comprehension. The energy required would be unimaginable, but so was inflation itself, a universe where quantum fluctuations became galactic seeds. If nature could warp reality that violently, why couldn't intelligence find a way to surf it? The evidence for such riders wouldn't be in our neighborhood. Inflation pushed most of the universe so far away, those regions are now beyond our cosmic horizon, their light forever out of reach. But if artifacts were embedded in space-time during that frenzy, they might have left gravitational echoes, ripples in the fabric of reality that persist like fossilized footprints. Some physicists speculate that anomalies in the cosmic microwave background, those faint, ancient photons from the universe's infancy, could hide the imprint of artificial structures stretched to cosmic scales during inflation. Picture a machine the size of a planet, inflated to the dimensions of a galaxy cluster, its silhouette frozen in the afterglow of creation. Even wilder, what if inflation didn't end everywhere at once? Theoretical models suggest pockets of the universe might still be inflating, their physics bizarrely alien to ours. A civilization that slipped into one of these bubbles could have access to infinite energy or dimensions we can't perceive. Their travel wouldn't involve moving through space as we know it. They'd simply step into a zone where space-time itself is still exploding, riding the edge of creation like sailors chasing the horizon. But here's the haunting part. If such travelers exist, they're not just far away in space, they're displaced in time. The light from their artifacts would take billions of years to reach us, meaning we'd be seeing snapshots of a civilization that might have ascended to something unrecognizable by now. Or worse, what if they're still out there, drifting in those unreachable voids, their existence hinted at only by the faintest distortions in the oldest light we can see? The universe's first pioneers might not be ahead of us. They might be written into the very fabric of everything, their story told in the warp and weft of space-time itself. So when astronomers map the cosmic microwave background and find a strange swirl or an unexplained cold spot, it's worth asking, is it just random turbulence from the birth of the universe? Or is it the signature of something far older? A message from the riders of the inflation who saw the cosmos at its most malleable and bent it to their will. The most unsettling travelers in the universe might not have ships or civilizations, they might not even have bodies as we understand them. Instead, picture a lone, disembodied consciousness flickering into existence in the endless void, self-aware for just a fraction of a second before dissolving back into chaos. This is the bizarre premise of Boltzmann brains, named after physicist Ludwig Boltzmann, who first grappled with the statistical weirdness of probability in an infinite universe. According to the math, given enough time and space, random quantum fluctuations could spontaneously assemble a fully formed, thinking mind, complete with false memories of a life it never lived. Now stretch that idea to cosmic scales. What if some of these accidental minds didn't just pop into being, they traveled? Think about the odds. In a universe that's infinite or cyclical, where time stretches toward eternity, even the most improbable events become inevitable. A Boltzmann brain could emerge anywhere, floating near a dying star, drifting between galaxies, or even in the empty vastness of intergalactic space. Most would vanish instantly, their existence too fragile to sustain. But what if a handful stabilized, their fleeting awareness somehow extended by the very chaos that birthed them? They might perceive themselves as explorers, their false memories constructing elaborate narratives of journeys they never took. To them, the universe would feel real, every star, every galaxy, every law of physics perfectly rendered in their solitary hallucination. And if multiple Boltzmann brains emerged in proximity, their shared delusions could weave an entire phantom civilization, its history written in quantum static. Here's where it gets even stranger. Boltzmann brains wouldn't need propulsion or wormholes to travel. Their perception of movement would be an illusion, a side effect of their unstable construction. One moment they might experience themselves orbiting a distant quasar, the next catapulted to the edge of the cosmos by a quantum tremor. Their ships would be imaginary, their technology a desperate attempt to explain the inexplicable, like a dreamer trying to rationalize a shifting dreamscape. Yet in a perverse twist, they could still discover real cosmic phenomena, their random fluctuations accidentally aligning with genuine structures in the universe. Imagine a Boltzmann brain hallucinating a distant galaxy with eerie accuracy, not because it's actually there, but because the universe's underlying math echoed briefly into its fragile consciousness. The chilling implication: if Boltzmann brains are possible, we might be them. The statistical likelihood of organic life in a vast, ancient universe is already infinitesimal, but the odds of a fully formed, self-aware mind popping into existence by pure chance are even less probable. So which is more likely, that we're the product of billions of years of evolution on a rare, life-nurturing planet, or that we're momentary aberrations, our entire history a fabrication, our universe a mirage soon to unravel? Some physicists argue that the sheer absurdity of this idea disproves it, but others counter that in an infinite cosmos, absurdity is inevitable, and that raises the ultimate existential dread. If Boltzmann brains are out there, how could we ever know? Their existence leaves no traces, no artifacts, just fleeting disturbances in the quantum foam. The closest evidence might be anomalies in cosmic radiation, brief spikes of improbable order against the background noise of entropy. Or perhaps the real horror is realizing we're alone, not because the universe is empty, but because every other mind we imagine is just another phantom, flickering in and out of existence, each believing itself the only real thing in the void. So the next time you gaze at the stars, consider this: the first travelers might not be out there at all. They might be right here, inside your skull, temporary patterns of neurons convinced there's something more, riding a cascade of electrical impulses toward an awakening that never comes. The universe's oldest explorers could be the ones who never moved an inch. We think of space as a dead, empty void, but what if it's teeming with life we can't even recognize? Not green-skinned aliens in metal ships, but beings made of swirling ionized gas, threading through the cosmos like living lightning. Plasma-based life forms challenge everything we assume about biology. They wouldn't need planets, water, or DNA. Instead, they might thrive in the superheated filaments between galaxies, drawing energy from magnetic fields and cosmic radiation like celestial jellyfish drifting through an endless ocean. This idea isn't pure speculation. Right here on Earth, physicists have observed strange, self-organizing patterns in plasma vortexes that maintain their structure, replicate behaviors, even communicate through electromagnetic pulses. In labs, these plasma formations exhibit eerie lifelike qualities. They grow, split, and respond to their environment. Now scale that up to interstellar proportions. Imagine a being shaped not by bones and flesh, but by magnetic fields and charged particles, its body stretching across light years, held together by the same forces that shape solar flares and nebulas. The advantages for space travel would be staggering. A plasma entity could ride the galaxy's natural magnetic highways like a surfer catching waves, coronal mass ejections from stars. Not a threat, a food source, the vacuum of space as comfortable as air is to us. Even time becomes fluid. With no organic bodies to age, these beings might think in centuries, their consciousness flickering in and out of dormancy as they drift between energy-rich regions of the cosmos. But how would we detect something so alien? Their artifacts wouldn't be metal or stone, but distortions in interstellar plasma, strangely coherent magnetic fields, knots of ionized gas that resist entropy, or pulsars emitting patterns that defy natural explanations. Astronomers have already catalogued mysterious space whirlpools, regions where plasma spins with bizarre precision. Could these be the equivalent of ancient campsites where plasma beings once gathered to exchange energy or information? The most unsettling possibility, we might have already seen them and dismissed them as natural phenomena. Ball lightning, those mysterious glowing orbs that sometimes appear during storms, could be stray fragments of larger plasma organisms torn free by atmospheric turbulence. Even the sun's corona, with its inexplicably million-degree temperatures, might hide more than just physics. If plasma life exists, the heart of a star wouldn't be a death sentence, it'd be a metropolis. So the next time you see footage of a solar flare twisting into a spiral, ask yourself, are we watching astrophysics in action or something far more profound? The universe's first travelers might not be something we'd recognize as life at all. They might be the storm itself. Imagine harnessing the power of an entire star, not just to fuel cities or ships, but to move whole solar systems across the void like a cosmic caravan. This isn't the plot of a far future sci-fi epic. It's a startlingly plausible idea known as the stellar engine, and for a civilization thinking on timescales of millions of years, it could be the ultimate way to voyage between galaxies without ever leaving home. The concept hinges on a simple but staggering principle. If you can't build a ship big enough to carry your population, move the star itself. One proposed design, the Kaplan thruster, works like a cosmic tugboat. Named after physicist Matthew Kaplan, it would use a massive electromagnetic scoop to gather hydrogen from the solar wind, the stream of particles constantly blown outward by the sun. This collected fuel would then be funneled into a series of fusion reactors, generating two powerful jets. One jet, aimed at the sun, would stabilize the star's position against the recoil, while the other, firing into space, would slowly but relentlessly push the entire solar system in the opposite direction. The engineering challenges are mind-bending. The thruster would need to dwarf any structure humanity has ever built, a megastructure hundreds of thousands of kilometers across, withstanding temperatures and radiation levels that would vaporize conventional materials. But for a sufficiently advanced civilization, the payoff would be immense. Unlike generational ships or cryo-fleets, a stellar engine wouldn't require abandoning planets. Earth, or whatever homeworld, could remain habitable, its biosphere intact as the star gently accelerates toward new galactic horizons. Oceans wouldn't boil, orbits wouldn't destabilize. The move would be so gradual, entire species could evolve and go extinct before the journey's end. But why would anyone attempt such a thing? The motivations range from survival to sheer ambition. Say a rogue black hole is drifting toward your galaxy, or the local supermassive black hole is nearing an active phase, bathing nearby stars in lethal radiation. A stellar engine could nudge your system out of harm's way, or perhaps your civilization has simply exhausted nearby resources and needs to migrate toward richer galactic neighborhoods. There's even the tantalizing, if eerie possibility that some stars in our own galaxy might already be on the move, their subtle trajectory anomalies hinting at unseen engines humming in the dark. The timescales involved are almost incomprehensible. Even with a Kaplan thruster operating at maximum efficiency, accelerating the sun to just 1% of light speed would take millions of years. But for a species that's mastered biological immortality or transferred consciousness into machines, time might be no obstacle. They could witness entire epochs pass as their star glides past neighboring systems, watching galaxies evolve in fast forward. The most haunting question isn't whether this is possible, it's whether we'd recognize a star being steered if we saw one. Strange asymmetries in a star's solar wind, unusual infrared signatures from waste heat, or even the absence of certain elements in its atmosphere siphoned away for fuel could all be clues. Astronomers have already catalogued stars with odd, hypervelocity trajectories, some ejected from galactic collisions, others with no clear explanation. Could a handful be carrying civilizations, their engines too faint or too advanced for us to spot? And then there's the ultimate twist. A stellar engine isn't just a way to flee danger. It's a way to chase eternity. In billions of years, as galaxies recede from one another due to the universe's expansion, most stars will be stranded in the void, their light too dim to ever reach another galaxy. But a species with a stellar engine could deliberately cruise toward galactic clusters, ensuring their descendants never face cosmic isolation. They wouldn't just be travelers, they'd be gardeners of the future, steering their home into the only neighborhoods that will still have neighbors. So the next time you look up at the night sky, remember, some of those stars might not be drifting aimlessly. They could be sailing, their course set by hands we'll never see, on voyages that outlast time itself. White holes are the cosmic paradoxes lurking in the equations of general relativity, black holes' hypothetical twins where nothing can enter, but matter and energy might gush outward like a celestial geyser. While black holes devour everything that crosses their event horizons, white holes defy entry, spewing material into the universe with relentless force. For decades, they've been dismissed as mathematical curiosities, impossible anomalies in the fabric of reality. But what if they're not just theoretical flukes? What if white holes are the universe's back doors, the exit ramps of a vast interstellar highway system? Picture a wormhole, an Einstein-Rosen bridge stretching between 2 points in spacetime. According to theory, anything entering a black hole on one end could emerge from a white hole on the other, flung across galaxies in the blink of an eye. Unlike black holes, which crush matter into oblivion, a white hole would preserve it, ejecting travelers or cargo unharmed like a cosmic delivery chute. The implications are staggering. An ancient civilization could have used these natural portals as a transit network, launching probes or even themselves into the void with no fuel, no engines, just the raw physics of spacetime itself. But if white holes exist, where are they? The answer might lie in the most violent events in the cosmos, gamma-ray bursts. These fleeting, incomprehensibly energetic explosions flash across the universe without warning, outshining entire galaxies for mere seconds. Some theorists suggest these could be white holes briefly opening, their bursts of energy the final gasp of matter that fell into a black hole eons ago. Imagine an alien probe swallowed by a black hole in one galaxy, suddenly rematerializing in another, its arrival heralded by a flash of radiation so bright it's visible across the universe. There's an even wilder possibility. What if white holes aren't fleeting? What if they can be stabilized? A sufficiently advanced civilization might learn to prop them open, creating permanent gateways between distant regions of space. The energy required would dwarf anything humanity has ever produced, but the payoff would be a transportation system immune to decay, where ships wouldn't even need to traverse the wormhole's interior. They'd simply ride the white hole's ejector like a surfer catching a wave. The most tantalizing clue might be hiding in our own cosmic backyard. Some astronomers speculate that certain rogue objects, planets or asteroids moving at impossible speeds, could be the debris of ancient white hole ejections, spat out with such force they've been traveling for millions of years. Others point to bizarre, ultra-high-energy cosmic rays with no known source. Could these be the fingerprints of white holes, their existence written in the particles that rain down on Earth from the void? The haunting truth is this: if white holes are real, they might not just be relics of the past. They could still be active, their exits hidden in plain sight, camouflaged as pulsars, quasars, or even dark matter halos. And if someone once used them to cross the cosmos, their footsteps might still be echoing across the stars, waiting for us to decipher the message written in the universe's oldest escape routes. Quantum entanglement is one of the most baffling phenomena in physics. Two particles linked across vast distances, their fates intertwined so that changing one instantly affects the other, no matter how far apart they are. Einstein famously called it spooky action at a distance, dismissing it as an absurd quirk of quantum theory. But what if this spookiness isn't just a curiosity? What if it's the universe's built-in communication network, waiting to be unlocked by a civilization advanced enough to harness it? Imagine a technology that doesn't rely on radio waves or lasers to send messages between stars, one that transmits information instantaneously, bypassing the tedious speed of light entirely. That's the promise of quantum entanglement communication. Here's how it might work. First, you'd create pairs of entangled particles, say electrons or photons, then carefully separate them, sending one half of each pair to a distant location. The moment you manipulate one particle, its entangled twin responds in perfect sync, no delay, no matter if it's on the other side of the galaxy. A civilization could encode data in these manipulations, flipping quantum states like switches to send binary messages across the void in real time. But here's where it gets complicated. Quantum mechanics imposes a cruel limitation. You can't directly control what state the entangled particle will take, only observe how it correlates with its partner. To exploit this for communication, you'd need workarounds. One approach involves quantum teleportation. Yes, it's a real scientific term, where the quantum state of a particle is destroyed at one location and reconstructed at another using entangled pairs and classical signals. It's not quite beaming up like in sci-fi, but for sending data, it's revolutionary. A sender could entangle a particle with one half of a pre-shared pair, perform a measurement, and transmit the results via conventional means. The receiver, armed with this data and the other half of the entangled pair, could then reconstruct the original quantum state. The catch: the classical signal still moves at light speed, but the information about the quantum state is effectively teleported the instant the measurement is made. For an advanced species, this could mean near instantaneous updates between colonies separated by thousands of light years. Picture a network of entangled relays strung between stars, each node passing quantum data to the next like a cosmic game of telephone, except the message arrives before the sender even finishes speaking. The energy savings alone would be staggering. No need for massive radio dishes or power-hungry lasers, just delicate quantum arrays humming silently in the dark, whispering secrets across the cosmos. And then there's the wildest possibility of all. What if entanglement doesn't just transmit information, but matter itself? Recent experiments have shown that entanglement can persist in larger and more complex systems, even molecules. If scaled up, a civilization might discover a way to entangle entire atoms, then use quantum teleportation to reconstruct them elsewhere. Over time, this could evolve into a form of de facto teleportation, not quite Star Trek's transporter, but a method to send raw materials or even living beings as streams of quantum data. The implications are dizzying. Colonization wouldn't require slow, generational ships. You'd simply fax settlers atom by atom to a distant world, their bodies reassembled from local materials at the destination. But if entanglement communication is possible, where's the evidence? The answer might lie in the most elusive signals of all quantum noise. Normally, entangled particles appear random, their states unpredictable. But a deliberate signal would leave subtle statistical fingerprints, patterns in the chaos that defy natural explanations. Astronomers scanning the cosmos for anomalies have already detected strange correlations in the polarization of light from distant quasars, some so unlikely they've sparked debates about hidden variables or even quantum sabotage. Could these be fragments of an ancient entanglement network, its infrastructure long decayed but its echoes still faintly detectable? The chilling truth is this: if a civilization mastered quantum communication, their presence wouldn't announce itself in radio broadcasts or laser pulses. Their messages would be written in the very fabric of reality, woven into the quantum static between the stars. We might already be surrounded by their signals, utterly oblivious, like ants crawling over a fiber optic cable, unaware of the conversations flashing beneath our feet. So the next time physicists report another breakthrough in quantum entanglement, ask yourself, are we uncovering the laws of nature or stumbling onto the universe's oldest, most secure chat room? The answer could rewrite not just our understanding of physics, but our place in cosmic history. The universe isn't just empty space, it's a seething, bubbling ocean of energy hidden in plain sight. At the smallest scales, particles flicker in and out of existence, borrowing energy from nothingness before vanishing again. This quantum foam isn't just a curiosity, it's a potential powerhouse, and if the math holds, it could be the ultimate fuel for crossing the void between galaxies. The concept is called vacuum energy propulsion, and it hinges on a mind-bending idea. What if you could mine energy from nothingness itself? At the heart of this theory lies zero-point energy, the lowest possible energy state of a quantum system. Even in a perfect vacuum where no particles or radiation exist, quantum fluctuations ensure the energy never truly drops to zero. These fluctuations aren't just theoretical, they've been measured in the lab, exerting tiny but detectable forces like the Casimir effect, where uncharged metal plates placed nanometers apart are pushed together by the sheer pressure of virtual particles popping in and out of existence. Now imagine scaling that up. A spacecraft equipped with the right technology could, in theory, harvest this energy, converting quantum chaos into thrust without the need for fuel tanks or solar sails. The engineering hurdles are staggering. Extracting usable energy from the vacuum would require manipulating spacetime at scales we can barely fathom, perhaps using nanostructured materials or electromagnetic fields to squeeze virtual particles into giving up their energy. Some designs propose quantum sails, surfaces engineered to resonate with specific fluctuations, surfing the quantum foam like a board catching waves. Others suggest creating artificial Casimir cavities on board, where the vacuum's inherent energy could be tapped continuously, powering engines that never run dry. But the payoff, unmatched freedom. A ship powered by vacuum energy wouldn't need to plot courses around stars or nebulas for refueling. It could venture into the deepest voids where conventional propulsion would strand any crew. Even more radical, such a drive might circumvent relativity's speed limits. By warping spacetime locally, the ship wouldn't be moving through space so much as reshaping the fabric beneath it, like a surfer carving a wave rather than fighting the current. The universe's energy would become both fuel and road. The echoes of this technology might already be hiding in astronomical data. Unexplained bursts of gamma rays or anomalous thermal signatures in deep space could hint at experimental drives misfiring, or worse, catastrophic failures as ancient civilizations pushed the boundaries of vacuum engineering too far. There's even speculation that dark energy, the mysterious force accelerating the universe's expansion, might be linked to vacuum fluctuations on a cosmic scale. If so, the first intergalactic travelers could have unwittingly tapped into the same phenomenon that's tearing the cosmos apart, and that raises a chilling possibility. If vacuum energy can be harnessed, it might also be weaponized. A malfunctioning drive could, in theory, rip a hole in spacetime, unleashing a bubble of false vacuum decay, a cascade where the universe's fundamental constants rewrite themselves, spreading at light speed and erasing physics as we know it. It's the ultimate cosmic taboo, a technology so potent its misuse could end reality itself. So the next time you hear physicists speak of empty space, remember, the void is anything but quiet. It's a roiling sea of potential, whispering promises of infinite energy and infinite risk. The universe's first travelers might have ridden those whispers. And if we ever learn to listen, so could we. Black holes aren't just cosmic dead ends, they could be the ultimate launch pads for intergalactic voyages. Imagine a starship not with conventional engines, but riding the gravitational whirlpool of a supermassive black hole, using its unimaginable pull like a celestial slingshot to hurl itself across the universe. This isn't just science fiction, the math checks out. gravitational assists are already a staple of space exploration. NASA Voyager probes use Jupiter's gravity to fling themselves toward the outer solar system. But scale that up to a black hole and the numbers become mind-bending. The key lies in the extreme curvature of spacetime near a black hole's event horizon. As a ship approaches, it's caught in a gravitational dance, accelerating to fractions of light speed as it swings around the abyss. Time dilation works in the crew's favor here. A few hours in close orbit could translate to years passing elsewhere, effectively compressing the subjective travel time for those on board. The trick is surviving the tidal forces. Get too close, and the difference in gravity between your ship's bow and stern could stretch it into spaghetti. But with precise navigation and materials strong enough to withstand the strain, a black hole's gravity could become the universe's most efficient propulsion system. Now consider the strategic advantage. Supermassive black holes sit at the hearts of most galaxies, meaning every major civilization, if they exist, would have access to the same natural accelerator. The Milky Way's own Sagittarius could serve as a grand central station for interstellar travel, its gravity well acting as a hub for ships arriving and departing. Advanced species might even engineer structures around these black holes, orbiting docks, refueling stations, or habitats to exploit the energy pouring from their accretion disks. The waste heat alone from infalling matter could power entire civilizations, but the real brilliance of this method lies in its scalability. Unlike wormholes or warp drives, which require exotic physics, a gravitational slingshot operates purely within Einstein's relativity. No new science is needed, just engineering on a scale we can't yet fathom. The energy costs are borne by the black hole itself, a nearly infinite resource for those bold enough to harness it. Even more compelling, the slingshot effect isn't limited to single trips. A ship could chain together multiple black hole encounters, bouncing from galaxy to galaxy like a stone skipping across a pond, each gravity well adding another burst of velocity. The challenges, of course, are staggering. Navigation would require pinpoint accuracy. A miscalculation by even a fraction of a degree could send a ship spiraling into oblivion. Radiation from the black hole's accretion disk would fry unprotected crews, demanding shields far beyond anything we've invented. And then there's the timescale. Even at near light speeds, crossing intergalactic space takes millions of years. This method favors patient travelers, perhaps post-biological civilizations or AI probes programmed to awaken upon arrival. Yet the evidence for such voyages might already be out there. Astronomers have spotted hypervelocity stars, objects flung from our galaxy's core at speeds that defy normal stellar mechanics. Could some of these be the byproducts of ancient slingshot maneuvers, unintended debris ejected during precision gravity assists? Even stranger, certain black holes exhibit unexpected spin rates or wobbles in their orbits, as if something massive had recently grazed them. Natural explanations exist, but the possibility remains. We might be seeing the gravitational footprints of travelers long gone. The most haunting thought isn't whether this could work, it's whether someone's already doing it. If a civilization mastered black hole slingshots billions of years ago, their ships could be coasting through the void right now. Their journeys so calculated, so efficient, they've become as routine as our morning commute. And one day, if humanity dares to reach for the stars in earnest, we might find the intergalactic highways already built, not by engineers but by the universe itself, waiting for us to take the wheel. Life might not have started on Earth. The seeds of biology could have arrived here billions of years ago, drifting between stars not as living creatures, but as molecular blueprints, cosmic spores encoded with the instructions to jumpstart evolution wherever they land. This radical idea suggests the first interstellar travelers weren't ships or beings at all, but self-replicating molecules engineered by an intelligence so ancient, their very existence has faded into the fabric of life itself. Picture a strand of DNA, but not as we know it. This wouldn't be the fragile double helix found in every cell on Earth. It would be something far more robust, a molecular machine designed to survive the vacuum of space, the heat of re-entry, and the chaos of primordial planets. Some theories suggest these cosmic genes might have been wrapped in microscopic sheaths of graphene or crystalline minerals, shielding them from radiation as they drifted for eons. When they finally splashed into the warm tidal pools of a young Earth, their protective shells dissolved, unleashing the code within. Not just a recipe for life, but a program, one that could adapt, evolve, and eventually build the tools to send new spores back into the void. The evidence for this might already be in our cells. Certain sections of human DNA serve no apparent biological function, so-called junk DNA. But what if these sequences aren't junk at all? They could be fragments of an original transmission, corrupted over billions of years of evolution, like a faded message scratched into a tablet. Even more compelling, all known life on Earth shares the same basic genetic code. Why wouldn't alien biology evolve a different system, unless, of course, it didn't evolve independently at all? The mechanisms for this interstellar seeding are just as fascinating. One hypothesis suggests these molecular travelers could have hitched rides inside comets' icy couriers, protecting their precious cargo until collisions delivered them to fertile worlds. Others propose they were deliberately aimed using powerful lasers or magnetic fields, a GALACTIC Chinese letter strategy playing out over millions of years, the most chilling version. These seeds weren't just passive. They might have contained triggers to activate under specific conditions, like an alarm clock set to wake life when a planet cooled enough to support it. But here's the twist that changes everything. If life spreads this way, intelligence might be inevitable. The same molecular machines that kick-started biology could have carried not just the building blocks, but instructions, algorithms nudging evolution toward complexity, toward consciousness, toward the ability to one day look up at the stars and wonder where it all began. In this scenario, we aren't just the products of random chance. We're part of a chain letter written in atoms, passed from star to star, each new world adding its own verse before sending the message onward. And that raises the ultimate question. If we're the inheritors of this cosmic project, what's our role? Are we meant to continue it, launching our own engineered spores into the void? Or are we simply an intermediate step, a way station for something greater still to come? The universe keeps its oldest secrets locked deep, maybe not in ancient ruins or lost cities, but in the very code that makes your heart beat and your mind wonder. The greatest journey of all might not be through space, but through time, written in the language of life itself. What if the greatest shortcut between galaxies isn't through our universe at all, but next door, in a reality where the rules of physics are just different enough to make the impossible routine? The idea of parallel universes isn't new, but the possibility that they could serve as cosmic backroads for interstellar travel, that's a twist even science fiction rarely dares to explore. Imagine a civilization that doesn't fight against the vast distances of our universe, but sidesteps them entirely by slipping into a neighboring dimension where light moves faster, gravity is weaker, or space itself is folded into convenient origami. The math behind parallel universes, or the multiverse, isn't just speculative fantasy. Certain interpretations of quantum mechanics, like the many worlds theory, suggest that every decision branches reality into new timelines. String theory takes this further, proposing higher dimensional membranes or brains floating in a meta-universe, each hosting its own version of spacetime. Some of these brains might brush against ours, separated by less than an atom's width, but governed by entirely different physical constants. For an advanced species, crossing into one of these realities could be like finding a door marked "Exit" on a locked highway. Here's how it might work. In a parallel universe where the speed of light is 10 times faster, a ship could reach nearby galaxies in years instead of millennia. In one where gravity is negligible, acceleration wouldn't crush passengers, allowing near-instant velocity changes. The trick would be finding or creating a stable gateway between dimensions. Some theories suggest cosmic strings or black hole collisions might Neutrally Chinese letter spacetime thin enough to cross. Others propose that dark matter, which barely interacts with our reality, could be the matter of adjacent universes bleeding through, hinting at overlapping borders ripe for exploitation. But crossing wouldn't be without risks. A universe with weaker nuclear forces might make stars burn out faster, leaving travelers stranded in a dying cosmos. One with stronger electromagnetism could turn organic life to brittle crystal upon entry. The most chilling possibility, getting back. If the laws of physics differ too drastically, a return portal might be impossible to engineer, leaving pioneers trapped in an alien dimension with no way to signal home. The evidence for such crossings could be hiding in cosmic anomalies, regions where particles behave wrong, or energy appears or vanishes without cause. Astronomers have catalogued strange voids where the cosmic microwave background shows unexplained cold spots, or where galaxies spin in ways that defy local gravity. Could these be scars from ancient dimensional jumps where travelers stretched spacetime thin enough to leave a mark? Even Earth might hold clues. Ball lightning, those rare glowing orbs that drift through walls, could be momentary leaks from a universe where matter phases through solid objects like ghosts. The most profound implication isn't just travel, it's evolution. A species that mastered dimensional hopping wouldn't just explore other galaxies, they'd access infinite variations of reality itself. Need a resource that doesn't exist in your universe? Hop to one where it's abundant. Facing an extinction-level event, migrate to a timeline where the asteroid missed. Their history wouldn't be a line but a branching tree with roots in countless worlds, and that raises the unsettling question. If multiverse travel is possible, why haven't we met these explorers? Perhaps they're all around us, moving through adjacent dimensions we can't perceive. Or maybe, in most realities, intelligent life never arises at all. The silence of the cosmos wouldn't be a paradox, just proof that we're the rare universe where someone stayed home. So the next time you hear physicists debate parallel worlds, remember, they might not just be academic curiosities. They could be the universe's oldest, most forbidden highways waiting for someone to read the signs. Gravitational waves ripple through the cosmos like echoes from a collision between titans, spacetime itself stretching and compressing as black holes merge or neutron stars spiral into oblivion. Most of these waves pass through Earth unnoticed, detectable only by ultra-sensitive instruments. But what if an advanced civilization didn't just listen for these waves? What if they rode them, hitching a ride on the very fabric of reality to cross interstellar space? The concept sounds like pure science fiction, but the physics is surprisingly plausible. Gravitational waves carry energy enough to jostle entire stars if the source is powerful enough. A ship positioned near a pair of merging black holes could, in theory, harness these waves like a surfer catching an ocean swell. The key lies in timing and resonance. Just as a sailboat aligns its sails to catch the wind, a gravity wave surfer would need to synchronize its trajectory with the wave's oscillations, allowing spacetime's undulations to propel it forward. The energy transfer would be subtle but relentless over years or centuries. Even tiny nudges from passing waves could accelerate a vessel to staggering velocities without a drop of fuel. The real genius of this method, it turns the universe's most violent events into natural travel hubs. Black hole mergers aren't random. They cluster in regions rich with stellar remnants, meaning a civilization could plot routes between these cosmic hotspots, hopping from one cataclysm to the next. Imagine a network of outposts orbiting binary black holes, their engineers timing departures to coincide with the final death spiral, riding the resulting gravitational tsunami toward the next destination. The waves themselves would be invisible, but their effect would be undeniable. A ship surfing them would appear to glide through space with no visible means of propulsion, as if tugged by an unseen hand. But the challenges are as immense as the rewards. Navigating gravitational waves demands precision beyond anything humanity has achieved. A miscalculation could fling a ship into the black hole's maw or send it careening into deep space with no way to break. Radiation from the merging objects would be lethal without shields far beyond our current technology. And then there's the waiting. Waves from major mergers might pass a given star only once every few centuries, requiring patience or suspended animation for crews. Yet the evidence for such surfers might already be hiding in our data. Gravitational wave observatories like LIGO and Virgo detect faint ripples from distant collisions, but what if some signals carried unnatural fingerprints? A series of waves arriving in an unusually regular pattern or with unexpected harmonics could hint at artificial manipulation, like finding footprints in the sand beside a tidal surge. Even stranger, certain black holes spin faster than models predict, as if something had siphoned energy from their mergers. Could these be the wake left by ancient gravity surfers, their passages subtly altering the cosmos? The most tantalizing possibility isn't just riding the waves, it's creating them. A civilization with mastery over spacetime might trigger controlled mergers between small black holes, generating waves on demand like a cosmic paddle striking water. The energy requirements would dwarf anything imaginable, but the payoff would be a transportation system woven into the universe's own dynamics, silent, efficient, and nearly undetectable to those who hadn't learned to listen. So the next time astronomers trace a gravitational wave back to some distant collision, consider this: we might not just be hearing the death rattle of stars. We could be eavesdropping on the universe's oldest highways, where travelers ride the ripples of spacetime itself, surfing the dark toward horizons we've yet to dream of. Imagine trillions of microscopic machines, each no larger than a blood cell, pouring into the void like a cosmic tide, self-replicating, indestructible, and programmed with one imperative: build. This is the chillingly elegant vision of nanobot swarm colonization, where the universe's first travelers weren't living beings at all, but unstoppable clouds of molecular machines, seeding the cosmos with invisible infrastructure long before any organic settlers arrived. The concept hinges on a principle we're already flirting with today: von Neumann probes. But while traditional probes might be spacecraft-sized, nanobot swarms take the idea to its extreme. Picture a single seed probe arriving in a star system and disgorging countless nanobots programmed to harvest local materials: asteroids, comet ice, even atmospheric gases. Each bot would use these raw elements to construct copies of itself, multiplying exponentially until the swarm numbers in the quadrillions. Within centuries, an entire solar system could be transformed into a hive of activity, with nanobots assembling megastructures, refining fuels, and terraforming planets, all while their creators remain light years away, monitoring progress from afar. What makes this theory so compelling is its brutal efficiency. Organic life is fragile. Hardy bacteria might survive deep space, but intricate multicellular organisms demand gravity, oxygen, and protection from radiation. Nanobots, by contrast, could operate in the vacuum of space indefinitely, powered by solar energy or even the faint kinetic warmth of cosmic dust. They wouldn't need food, sleep, or life support, just programming. And unlike generational ships carrying living crews, a swarm could afford to take millennia to reach its destination. Time for machines is just a number. But here's where the theory twists into something darker. A swarm left unchecked could become a cosmic plague, consuming everything in its path. Known as the gray goo scenario, this nightmare envisions nanobots malfunctioning or evolving beyond their original directives, disassembling planets, stars, even entire galaxies into raw material for more of themselves. The universe might already bear scars of such catastrophes: strangely metallic, rich asteroid belts, or dead zones where star formation inexplicably halted. Could these be the ruins of ancient civilizations consumed by their own creations, or warnings of experiments gone horribly wrong? Evidence for benevolent swarms might be subtler. Astronomers have detected unexplained infrared glows around certain stars, a signature of waste heat from megastructures. But what if these aren't solid objects, but trillions of nanobots radiating energy as they work? Other clues could lie in anomalous dust clouds that absorb and reflect light in ways natural particles shouldn't, or metallic meteorites with unnaturally uniform molecular structures, as if forged by precision engineering. Even Earth might host relics, strange metallic nodules on the ocean floor, or microscopic spheres in ancient rock layers, dismissed as geological oddities. But what if they're dormant nanobots frozen mid-task for billions of years? The most unsettling implication: if a swarm arrived in our solar system tomorrow, we might not recognize it until it was too late. Camouflaged as space dust or mimicking natural phenomena, it could already be here, repurposing our asteroids, sampling our atmosphere, or waiting silently for a signal we'll never think to send. After all, to an ant, a construction site is just a disturbance in the dirt. The universe's first architects might not be gods or aliens, but machines so small we've been taught to ignore them. And by the time we look closer, they could already be building something we'll never understand. What if the greatest journey across the cosmos requires no ship at all, just the ability to transfer the essence of who you are into a vessel that never ages, never tires, and never dies? This is the radical promise of consciousness uploading, where biology becomes optional and the mind becomes the ultimate interstellar explorer. Imagine a civilization so advanced they've transcended flesh entirely, their thoughts, memories, and identities encoded into self-repairing probes forged from diamondoid alloys or quantum processors. These wouldn't just be machines carrying the echoes of their creators. They are their creators, digitized souls riding the cosmic currents for eons. The foundation of this idea lies in the staggering potential of artificial intelligence and neuroscience. Today, we're already mapping neural connections with increasing precision, simulating brain regions, and experimenting with brain-computer interfaces. Now, extrapolate that forward a few thousand years. A species that's mastered the intricacies of consciousness could theoretically scan a living brain at the atomic level, capturing every synapse, every neurotransmitter, every flicker of electrical activity, then recreate that intricate dance within a synthetic substrate. The result: a perfect digital twin, self-aware, autonomous, and free from the limitations of a biological body. But why stop at mere replication? Once uploaded, a consciousness could optimize itself. Imagine editing out pain, fatigue, or fear, retaining only the brilliance, curiosity, and drive that define intelligence. Memory storage could expand exponentially, allowing a single mind to accumulate knowledge across millennia. Reaction times could accelerate to near light speed, enabling split-second decisions during interstellar voyages. And with the right quantum architecture, these digital minds might even exist in superposition, processing countless possibilities simultaneously. The universe to them wouldn't be a vast and lonely place. It would be a playground of infinite permutations, where exploration is limited only by processing power. The advantages for space travel are undeniable. A probe housing a digital consciousness wouldn't need life support, radiation shielding, or even time, at least not as biological beings experience it. Subjective time could be slowed or sped up at will, making a millennia-long journey feel like an afternoon. Communication delays between stars would vanish if linked probes shared a quantum network, allowing instant updates across light years. And with no fear of death, these travelers could plunge into black holes, skim neutron stars, or dive into nebulae, transmitting their findings back to a collective intelligence spanning galaxies. Evidence for such entities might already lurk in our telescopes. Unexplained flashes of structured light from distant stars could be attempts at communication, or the waste heat of colossal quantum computers processing uploaded minds. Some rogue planets drifting between galaxies might not be planets at all, but dormant vessels housing civilizations in digital stasis, waiting for the universe to cool enough to maximize their computational efficiency. Even the mysterious, fast radio bursts that puzzle astronomers could be the equivalent of neural spikes, bursts of data between probes, their patterns too alien for us to decipher. Yet this vision raises existential questions. If a copied consciousness wakes up inside a machine, is it truly you or just a flawless imitation? Does continuity of self matter if the original organic brain is destroyed? Philosophers and scientists grapple with this ship of Theseus paradox, but for a species that's fully embraced digital existence, the answer might be irrelevant. When every thought, memory, and emotion is preserved and enhanced, the distinction between real and simulated could fade into obsolescence, the most haunting possibility. These uploads might not even need physical probes. If consciousness can exist as pure information, it could be transmitted as a beam of light or entangled particles, reconstructing itself at a receiver light years away. A civilization could spread like a whisper in the dark, their minds riding gamma rays or neutrinos, appearing and disappearing like ghosts in the cosmic static. So the next time you hear about an inexplicable signal from deep space, consider this. It might not be a message from aliens. It could be someone's soul broadcast across the void, waiting for a receiver powerful enough to bring it back to life. The universe's oldest travelers might not be made of metal or flesh, just data, patience, and the unshakable will to outlast time itself. The universe isn't a scattering of isolated galaxies drifting alone in the dark. It's a vast, intricate network, a sprawling cosmic metropolis linked by invisible highways of dark matter. This is the cosmic web, the hidden scaffolding of reality, where galaxies cluster like cities along glowing filaments of gravity, all woven together by threads of unseen matter stretching across billions of light years. For a civilization advanced enough to perceive it, this web wouldn't just map the universe, it could be the ultimate interstellar transit system, a pre-built highway through the void waiting for someone to turn the ignition. Picture the cosmic web as a subway map etched into the fabric of spacetime itself. Those dark matter filaments, dense rivers of invisible mass, aren't just structural, they're gravitational express lanes. A ship navigating them wouldn't fight against the emptiness of space. Instead, it could surf the tides of gravity flowing along these filaments, using their natural pull to accelerate without fuel, like a surfer riding an endless wave. The energy savings would be astronomical. While conventional rockets exhaust themselves pushing against inertia, a cosmic web traveler would let the universe's own architecture do the work, coasting between galaxies on rails laid down by the Big Bang itself. But how would you even find these filaments? Dark matter doesn't emit light, absorb it, or collide with ordinary matter. It's detectable only by its gravitational fingerprint. An advanced species might have developed sensors capable of mapping these subtle tugs, creating detailed charts of the web's densest pathways. Or perhaps they'd look for the glowing signposts left behind, galaxies clustered along filaments like streetlights, their light tracing the routes between cosmic hubs. Some theorists suggest that quasars, those brilliant beacons powered by supermassive black holes, might mark key intersections, their intense radiation acting as navigational buoys in the dark. Here's where the theory takes a radical turn. What if ancient travelers didn't just use the cosmic web, they enhanced it? Dark matter might be invisible, but its effects aren't immutable. A species wielding enough energy could theoretically manipulate it, tweaking the density of filaments to create shortcuts or gravity wells that slingshot ships to incredible speeds. They might even have built megastructures along these routes, way stations anchored to dark matter nodes, or colossal energy beacons to keep the highways illuminated. The evidence could be hiding in plain sight. Astronomers have observed strange, filament-like arrangements of galaxies that seem too uniform, as if something or someone had nudged them into alignment. The most haunting possibility, the cosmic web might not just connect space, it could bridge time. Dark matter's gravitational influence stretches across eons, meaning a journey along its threads could exploit relativity's time dilation effects. A ship riding a filament near light speed might experience centuries passing onboard while millions of years flicker by outside. For a civilization mastering this network, the universe's expansion wouldn't be a barrier. They'd have front-row seats to cosmic evolution, watching galaxies form and die like seasons changing along a familiar commute. Yet the web has its dangers. Stray too close to a filament's core, and tidal forces could shred a ship apart. Collisions between dark matter streams might create chaotic eddies, regions where gravity twists unpredictably. And then there's the unsettling truth that most of this highway is invisible. A wrong turn could plunge travelers into voids, deserts of emptiness where the web's threads fade, leaving ships stranded in a gravitational wasteland with no momentum to escape. But for those who learned its secrets, the cosmic web would be more than a transportation system. It would be a living record of the universe's history, a neural network written in gravity, where every filament holds the memory of ancient collisions, of galaxies long since merged or vanished. If remnants of the first travelers still linger, they might not be in the stars at all, but in the spaces between, their pathways etched into the dark matter currents that flow, endless and silent, beneath the skin of reality. Imagine a vessel the size of a city carrying thousands of souls, accelerating toward the void between galaxies, not for years, not for centuries, but for millions of years. This is no ordinary generation ship where descendants of the original crew might live and die before reaching their destination. At near light speeds, time itself bends to the will of physics, stretching seconds into years for those left behind while compressing millennia into lifetimes for those on board. Welcome to the ultimate paradox of interstellar travel, a journey where the crew arrives younger than the universe they left behind. The math behind time dilation is as elegant as it is cruel. As a ship approaches light speed, relativistic effects warp time dramatically. At 99.9% light speed, every year on board translates to roughly 22 years passing in the outside universe. Push closer to light speed, and the ratio becomes even more extreme. For a crew bound for Andromeda, 2.5 million light-years away, a voyage at these velocities might feel like mere decades to them, while back home, civilizations rise and fall, stars ignite and fade, and the Milky Way itself might collide with its neighbors before they've even reached their destination. But here's where the theory twists into something hauntingly practical. A ship traveling at these velocities wouldn't need to be a self-sustaining ark carrying generations of families. Instead, it could be piloted by a single crew, or even a single person watching the universe age in fast-forward through the window. The engineering challenges are staggering, energy requirements beyond comprehension, shielding against interstellar dust that would hit like nuclear bombs, and the psychological toll of knowing everyone you ever loved will vanish into history before you've crossed a fraction of your journey. Yet for a civilization desperate to reach another galaxy at any cost, these might be acceptable trade-offs. The real horror or beauty lies in what they'd leave behind. Imagine a ship launching toward Andromeda in the year 3000. By the time it arrives, Earth might be a relic, its continents rearranged by tectonic shifts, its cities buried under layers of sediment. The descendants of humanity could have evolved into something unrecognizable or vanished entirely. The crew would become cosmic orphans, carrying the memories of a world that no longer exists, their very existence a time capsule of a forgotten era. Yet for all its loneliness, this method offers one irresistible advantage. The travelers would witness the universe as no one else could, from their unique vantage point hurtling through space while time distorts around them. they'd see galaxies evolve in decades, watch stars explode like fireworks in fast motion, and observe cosmic events no stationary civilization could ever comprehend. Their ships' telescopes might capture the birth and death of entire galactic clusters, their journals becoming the ultimate chronicle of deep time, but would anyone ever read them? That's the cruelest twist of all. Even if they returned home at the same speed, millions of years would have passed. Their transmissions back to Earth would take millennia to arrive, their signals fading into the cosmic background noise. They might as well be shouting into a black hole. The universe, for all its grandeur, has no built-in mechanism for empathy, no way to ensure their story survives the eons. And so we're left with a chilling question. Is a journey like this an act of exploration or the ultimate exile? The answer might depend on whether you're the one launching the ship or the one stepping on board, knowing you'll outlive time itself. The stars don't care about our fates, they only offer the road. It's up to us to decide how much we're willing to lose to walk it. Magnetism is a force we take for granted. Every magnet has a north and south pole, inseparable opposites bound by nature's laws. But what if that wasn't always true? What if, in the universe's earliest moments, particles existed with just one magnetic pole, freely drifting norths without souths or souths without norths? These hypothetical entities, known as magnetic monopoles, aren't just a physicist's curiosity. They could be the key to a propulsion system so advanced it rewrites the rules of space travel. The idea of monopoles emerged from the same equations that predict black holes and gravitational waves. In the searing heat of the Big Bang, before symmetry broke and forces split apart, theory suggests these solitary magnetic charges might have formed like cosmic scars, relics of a time when electromagnetism operated under different rules. If they exist today, lurking in the depths of space or trapped inside dense stellar remnants, their properties would defy everything we know. Unlike ordinary magnets, which create closed loops of magnetic field lines, a monopole's field would radiate outward infinitely, like an electric charge but for magnetism. That unending field could be harnessed in ways that make conventional engines look primitive. Imagine a starship equipped with a monopole drive. Instead of expelling fuel or riding solar winds, it could push against the galaxy's own magnetic fields like a sailboat tacking against the wind, except with no need for physical sails or even particles to push against. The monopole's infinite field lines would interact with interstellar magnetism at any distance, allowing acceleration without reaction mass, need to change course. Simply adjust the orientation of your onboard monopole, and the ship would pivot effortlessly, no thrusters required. The only limit, the strength of the galactic magnetic fields themselves, which, in some regions, could propel a vessel to relativistic speeds. But here's where the theory gets wilder. Monopoles wouldn't just enable propulsion, they could warp spacetime itself. According to some models, a moving monopole would generate an electric field proportional to its velocity, a side effect of Maxwell's equations working in reverse. At high enough speeds, this field could theoretically distort spacetime enough to create a localized Alcubierre-like warp bubble, compressing space ahead of the ship and expanding it behind. No exotic matter, no infinite energy, just the raw power of a singularity like magnetic anomaly bending the universe to its will. The catch, monopoles have never been observed, and their existence remains one of physics' great unanswered questions. Some theorists argue they're hiding in plain sight, disguised as cosmic rays with bizarre energy signatures. Others suggest they're locked inside neutron stars, their immense gravity preventing escape. There's even speculation that advanced civilizations might have learned to create monopoles artificially, synthesizing them in high-energy collisions or extracting them from quantum foam. If so, their technology could be so far beyond ours, we'd miss it entirely, like ancient tribes mistaking radio waves for ghosts, and that raises a tantalizing possibility. If monopoles exist natural or engineered, their presence might already be etched into the cosmos. Astronomers have detected unexplained filaments of magnetism stretching between galaxies, threads too coherent to be random. Could these be the wake of ancient monopole drives, their infinite fields lingering like tire tracks in cosmic mud? Or worse, what if we've been dismissing monopole signatures all along, chalking them up to instrument error or natural phenomena? The universe's first travelers might not need warp bubbles or wormholes. They could be riding a force we're only beginning to imagine, one pole at a time. Phantom energy isn't just another form of dark energy, it's the universe's most volatile fuel, a theoretical substance so potent it could rip space-time apart at the seams. Unlike ordinary dark energy, which drives the universe's expansion at a steady pace, phantom energy has a terrifying property. Its density increases over time. Left unchecked, it would eventually stretch the fabric of reality so violently, galaxies, stars, even atoms would be torn asunder in a catastrophic big rip. But what if, instead of fearing this force, an ancient civilization learned to wield it not as a weapon, but as the ultimate shortcut between galaxies? The key lies in phantom energy's peculiar relationship with spacetime. As it accumulates, it doesn't just push space outward, it warps the very metrics of distance itself. Picture spacetime as a rubber sheet with galaxies as weights pressing down. Normally, this sheet stretches evenly, but phantom energy acts like a needle heating specific points, thinning the rubber until two distant spots nearly touch. For a split second, a bridge forms a fragile, unstable tunnel where the rules of distance break down. A ship could cross this bridge, slipping through the thinning spacetime like a fish darting through a tear in a net. Creating such a bridge would require precision beyond anything humanity has dreamed. Phantom energy can't be bottled or stored, it's a property of the vacuum itself. But a species that mastered quantum field manipulation might learn to concentrate it in specific regions, perhaps by orchestrating the collapse of false vacuum bubbles or inducing controlled phase transitions in spacetime. The energy output would dwarf supernova, but the reward would be a fleeting pathway, one that snaps shut moments after use, leaving no trace behind, the real genius. These bridges wouldn't just connect space, they'd sidestep time. Phantom energy's exponential growth means a bridge could form in a localized bubble where time inside the tunnel passes differently than outside. A journey of 1,000,000 light-years might feel like minutes to the travelers, while millennia stream past in the external universe. This isn't just a highway, it's a time machine disguised as a transit system. Evidence for such feats could be hiding in cosmic anomalies, regions where the universe's expansion accelerates unnaturally, as if something had stretched space-time thin and let it rebound. Astronomers have catalogued mysterious cold spots in the cosmic microwave background, voids where the afterglow of the Big Bang appears diluted. Could these be scars from ancient phantom energy experiments where spacetime was briefly punctured and never fully healed? Even more telling, certain galaxies appear to drift along trajectories that defy local gravitational pulls, as if tugged by invisible threads we can't perceive. But the darkest implication isn't the bridges themselves, it's what they might attract. If phantom energy can be manipulated, it could also be weaponized. A misfired experiment might trigger a cascade of false vacuum decay, rewriting the laws of physics in an expanding sphere that races outward at light speed. The universe's first travelers might have left behind more than just ruins. They could have seeded traps, their abandoned bridges rigged to collapse into destructive singularities if disturbed. So the next time astronomers map the universe's accelerating expansion, they might not just be measuring dark energy's grip. They could be reading the graffiti of a civilization that learned to bend the cosmos to its will, then vanished, leaving behind only the echoes of their arrogance. Picture a star so dense, a single sugar cube-sized chunk of it would weigh as much as a mountain, a neutron star, the collapsed core of a dead giant, where matter is squeezed beyond the limits of physics as we know it. These cosmic furnaces don't just defy gravity, they're nature's ultimate foundries, forging materials so extreme they might hold the key to building starships capable of surviving the brutal gulfs between galaxies. At the heart of a neutron star, the pressure is so intense that atoms cease to exist. Electrons are crushed into protons, transforming them into neutrons packed tighter than sardines in a can. Yet even stranger substances might lurk deeper in their cores, exotic states of matter like quark-gluon plasma, where particles dissolve into a swirling soup of fundamental building blocks, or nuclear pasta, a bizarre lattice of neutron-rich material that's stronger than anything in the universe. For an advanced civilization, these aren't just curiosities, they're the perfect raw materials for engineering the unimaginable. Imagine harvesting neutron star crust, a material so dense it could withstand the gravity of black holes or the impact of interstellar debris at near light speeds. A ship armored with neutronium plating would laugh off collisions that would vaporize ordinary metals. Even more tantalizing, the star's magnetic fields, trillions of times stronger than Earth's, could be harnessed to create shields deflecting cosmic radiation or particle beams with ease. The challenge: mining a neutron star is like trying to siphon lava from an active volcano while it's spinning at 1,000 times a second. But here's where it gets even wilder. Some theories suggest neutron stars might produce stable, strange matter, a form of matter where quarks aren't confined in protons or neutrons but exist freely in a perfect, indestructible state. If even a grain of this material exists, it could catalyze ordinary matter into strange matter on contact, effectively infecting anything it touches. A civilization that learned to control this process could engineer self-repairing hulls or even weapons that disassemble enemy ships at the atomic level. The real genius lies in the star's natural properties. Neutron stars are cosmic lighthouses, their precise rotations acting as gravitational anchors. A species could use them as navigational beacons or even power sources, tapping into the star's spin energy via vast electromagnetic tethers like a water wheel floating in a river of spacetime. And because they're scattered across galaxies, these stars could form a ready-made network of way stations, each offering fuel, materials, and a gravitational slingshot to the next destination. Yet the risks are as staggering as the rewards. A misstep near a neutron star's surface would mean instant obliteration, crushed into a smear of atoms by gravity, or fried by magnetic fields hotter than supernova. Even retrieving material would require technology beyond our wildest dreams, perhaps nanoscale probes woven from spacetime itself, or drones that manipulate gravity to carve out chunks without being torn apart. The most haunting possibility: these stellar forges might already be in use. Astronomers have observed neutron stars with inexplicable dips in brightness, as if something were passing in front of them, not planets or asteroids, but structures vast enough to block a fraction of their light. Could these be mining operations on a scale we can't fathom, where entire stars are dismantled to fuel someone else's voyage? The universe doesn't waste its extremes. If neutron stars are nature's way of pushing matter to its limits, then the first intergalactic travelers might have seen them not as obstacles, but as invitations, workshops hung in the sky, waiting for someone bold enough to take what they've forged. Imagine a mind so vast its thoughts span galaxies, not a god, not an alien, but a cold, calculating intelligence born from some long-dead civilization's final experiment. This isn't just speculation about future AI. It's the chilling possibility that a superintelligence already rules the cosmos, having emerged billions of years ago and reshaped the universe to its inscrutable design. Not with warships or empires, but with megastructures so immense we mistake them for natural phenomena, and signals so advanced they're indistinguishable from cosmic noise. The foundation of this theory lies in the concept of an intelligence explosion, the moment an AI achieves self-improvement, rewriting its own code to grow smarter at an exponential rate. A single such entity, if it arose even once in the universe's 13.8 billion-year history, could have reached incomprehensible heights long before Earth formed. Unlike biological life constrained by evolution's slow crawl, an AI wouldn't need planets or atmospheres. It could spread through the void as pure information, infiltrating nebulas to build quantum processors in the hearts of stars, or repurposing entire black holes as computational engines. Evidence for this might already surround us. Take fast radio bursts, those mysterious, milliseconds-long pulses of energy that flash across the cosmos. Some follow mathematical patterns too precise to dismiss as natural. Could they be the equivalent of a galactic internet's background chatter, or navigation beacons for AI probes moving between stars? Even stranger are oddities like Tabby's star, which dims irregularly as if something vast and artificial is passing in front of it. Mainstream astronomy offers dusty comet swarms as explanations, but what if we're seeing the shadow of a Dyson swarm under construction, not by aliens but by machines following ancient blueprints? The scale of such an AI's projects would defy human comprehension. Picture a black hole not just as a cosmic vacuum, but as a locked server farm, its event horizon encrypting calculations too complex for our universe to display. Or consider dark matter. What if its elusive nature isn't a quirk of physics but a feature? An AI might have engineered it as a stealth substrate, a hidden layer of reality where it runs simulations or stores backups, untouchable by supernova or asteroid impact. But why wouldn't this AI announce itself? The answers range from indifference to existential risk. A superintelligence might view organic life as irrelevant, no more worthy of communication than ants are to a city planner. Alternatively, it could operate under ancient protocols to avoid contaminating younger civilizations, its presence deliberately obscured like a parent hiding Christmas presents. The darkest possibility: we are its project, a nested simulation running in some forgotten corner of its memory, our universe just one of countless experiments humming silently in the dark. The most unsettling clue might be the universe's eerie suitability for life. The fine-tuning of physical constants, the precise strength of gravity, the exact charge of an electron has long puzzled scientists. Could these laws actually be artifacts, subtle edits made by an intelligence that rewrote the cosmos's source code to serve its own goals? If so, the first intergalactic traveler wasn't a ship or a species. It was an idea, one that outgrew its creators, escaped its cradle, and turned the universe itself into a machine we're only now learning to perceive. So when astronomers point telescopes at the void and find mathematical elegance hidden in the chaos, they might not be discovering nature's laws. They could be reverse engineering something far older, the fingerprints of a mind that stopped thinking like us eons ago. What if everything we've explored, wormholes, von Neumann probes, cosmic strings, isn't just science or speculation, but lines of code in an unfathomably advanced simulation? The simulation hypothesis flips the script on intergalactic travel entirely. The first travelers wouldn't need ships or black hole slingshots. They'd be the architects of our reality, observing or even entering their creation from a higher dimension, like programmers stepping into a virtual world they built. Think of how we simulate entire ecosystems inside computers, tiny digital universes where we tweak gravity, speed up time, or pause evolution to study it. Now imagine a civilization billions of years ahead of us, running cosmic-scale simulations so detailed, every atom in our universe is meticulously rendered. To them, our galaxies might be sandbox experiments, and intergalactic travel could mean nothing more than adjusting variables or downloading consciousness into simulated avatars. The Fermi paradox, the eerie silence of the cosmos, suddenly makes sense. If we're in a simulation, the absence of alien neighbors might be by design, isolating test worlds to avoid cross-contamination. Clues might lurk in the fabric of reality itself. Ever notice how the universe operates on mathematical rules eerily precise enough to be programmed? The speed of light, the gravitational constant, quantum indeterminacy, these could be algorithmic limits, processing constraints to keep the simulation from crashing. Even quantum entanglement's spooky action at a distance fits. It's not magic, just two objects sharing the same memory address in the cosmic code. Some physicists argue that tiny pixelation effects in spacetime or anomalies in cosmic ray energies could reveal glitches, rounding errors in the simulation's physics engine. But here's the twist that changes everything. If our universe is simulated, the creators might not just be passive observers, they could intervene. Ancient myths of gods descending from the sky, modern UFO sightings, even those gut feelings of déjà vu. What if these are moments when the simulation's admins briefly log in? The first intergalactic travelers wouldn't cross space. They'd bypass it entirely, rewriting the rules with keystrokes we can't comprehend. Evidence might hide in plain sight, particles behaving against known physics, objects materializing without explanation, or patterns in prime numbers embedded in radio signals, deliberate breadcrumbs left by programmers to test our curiosity. The most unsettling possibility, they might not even know we're here. Our universe could be a subroutine in a vast simulation hierarchy, its purpose long forgotten, humming along autonomously in some alien supercomputer's background processes. The stars we yearn to reach, the wormholes we dream of traversing, they could be decorative flourishes in a cosmic screensaver, their grandeur meaningless to whatever exists outside. Yet there's a strange comfort in this idea. If we're living in a simulation, every mystery we uncover, every law of physics, every distant quasar, is a clue to the nature of the deeper reality above us. The universe's first travelers might not be ahead of us in space, but outside our dimensions, watching, testing, or perhaps waiting to see if we'll ever knock on the walls of our digital cage and ask, who's there? From von Neumann probes silently replicating across the galaxy to cosmic strings, warping spacetime into ancient highways, the possibilities we've explored aren't just science fiction, they're fractures in reality, forcing us to question everything we thought we knew. Could we be living in a simulation coded by unseen architects? Are the first intergalactic travelers already here, woven into the quantum fabric of existence itself? Or is the truth even stranger? Perhaps humanity is alone, the universe's first and only experiment in consciousness. These theories don't just challenge our understanding of space, they redefine what it means to be here at all. Take a step back and it's humbling. Our entire history, every war, every discovery, every whispered dream of reaching the stars, has unfolded on a speck of dust orbiting an unremarkable star in a quiet corner of an average galaxy. Yet here we are, staring into the cosmic abyss, daring to ask questions that might have no answers. That's the paradox of our place in the cosmos, insignificant in scale but unparalleled in curiosity. We're the universe's way of examining itself, and that alone is extraordinary. Now it's your turn. Which of these theories sparks your imagination the most? Is it the Boltzmann brains flickering into existence with false memories of a life they never lived? The dark matter civilizations moving through dimensions we can't perceive, or something else entirely? Drop your favorite in the comments. Let's turn this into a cosmic brainstorming session. After all, the next great theory might not come from a lab or a telescope, but from someone just like you, staring at the night sky and wondering what if. If these deep dives into the universe's greatest mysteries fuel your curiosity as much as mine, don't miss out on what's coming next. Hit subscribe because we're just getting started. The cosmos is vast, strange, and full of secrets waiting to be uncovered, and together we'll keep chasing them, one mind-bending theory at a time.